hopefully everybody can hear my voice, and they're otherwise, if they can't hear anything, they're watching me point at this sign and hopefully getting their sound up and running. This lesson is on section 442, so that's chapter 4, section 4, part 2, in the Geometry Chapter 4 study guide. At the beginning of this chapter, earlier in the chapter, we talked about how to establish that two triangles are congruent. So the first thing we talked about was that we'd have to find three pairs of angles, this one, and this one, and three pairs of sides, 1, 2, 3, that are congruent. And once we had those 6 things established, then we could state that these two triangles were congruent. Or any two triangles are congruent when you have 3 pairs of corresponding angles and 3 pairs of corresponding sides. And then in the next section, we talked about how you don't actually have to do establish all 6 congruences. There are some things that are what I like to call shortcut theorems, where one of them is all you have to do is establish 3 pairs of corresponding sides. It's called side-side-side congruence. And then you could go ahead and just shortcut right to your conclusion that the two triangles are congruent, skipping over the angles. The next shortcut theorem was side-angle side congruence. So as long as you could establish a side, an angle, and a side where the angle was in between the two sides as corresponding pairs of congruent items from one triangle to the other, side angle side and side angle side, you could prove two triangles are congruent. That's the second shortcut theorem. This lesson is on the third shortcut theorem, called hypotenuse leg, or HL for short. The leg in a right triangle is either one of the two sides that come together to form the 90-degree angle. So if this is your right angle, then these two would be your legs. The hypotenuse on a right triangle is the side opposite from the right angle. So if this is your right angle, then that's your opposite side. It's also the longest side of your right triangle. So the hypotenuse leg congruence theorem says that if you can establish that the hypotenuse of one right triangle is congruent with the hypotenuse of another right triangle, and one of the legs is congruent to the corresponding leg on the other side, so this is your hypotenuse and that's your leg, hypotenuse and leg, that you can state that the two triangles are indeed congruent. Now remember, it has to be a right triangle for this to work, so keep that in mind. So, can we prove that these two right triangles are congruent? Do we have a hypotenuse congruent with a hypotenuse? Well, yeah, HJ would always be congruent with itself, right? According to the reflexive property. So we have our hypotenuse-hypotenuse connection. Do we have a pair of legs that are congruent? Well, the leg here and the leg here are congruent, so we have leg-leg. So on the top triangle, we have hypotenuse leg, and on the bottom triangle, we have hypotenuse leg. So, can we prove that these two triangles are congruent by hypotenuse leg? Yep. This one? Well, these aren't right triangles, are they? So, because this theorem only works with right triangles, I'm going to say we can't use the theorem and move on. So let's do one proof using the hypotenuse leg congruence theorem. Okay, here we go. We have the hypotenuse here matching with the hypotenuse there, and now we just need to establish that there's a leg that matches with another leg. Now if I look at this side right here, That is the short leg on the top right triangle and the short leg on the bottom right triangle. So this would be my L. So the top, I have hypotenuse leg, and on the bottom triangle, I have hypotenuse leg. Corresponding sides, the hypotenuse on each is congruent, and there's a leg pair on each that is congruent. So yes, I can go ahead and make a theorem, or make a proof that uses the theorem of hypotenuse leg to prove that these two triangles are congruent. And there's really only one thing I need to prove. These two are already stated in the congruence, it's in the given. And this one, ON, would simply have to be congruent with itself, and that's easy because that's the reflexive property. So if I establish all this information, if I put all this information into a proof, I'm going to start with the given that MN is congruent to OR, that MO is perpendicular to ON, and ON is perpendicular to NR. Remember that the hypotenuse leg theorem only works with right triangles, so I'm going to say that triangle MNO and triangle RON are right triangles. And I know that because each of them has a 90-degree angle in it. So by the definition of a right triangle, I know that to be true. Number 3, I could state that ON is congruent with itself because of the reflexive property. And then finally I'd be able to say that triangles MNO and RON are congruent with each other because of the hypotenuse leg congruence theorem.